So for this part, we're just going to play around with some curious questions and see if we can discover what's going on. These are actually from the homework questions. They're from part M. There's number 7, 8, and 9. That's why they're not on your homework assignment, because we're doing them together. So what's true about the nth derivative, so meaning whatever derivative of this function, once that number derivative gets greater than or equal to 4? So let's go ahead and find out what the fourth and fifth and sixth derivative is and see what happens. So this isn't too bad because we're talking about the power rule. So the first derivative is going to be 3x squared plus 6x plus 2. The second derivative is going to be 6x plus 6. The third derivative is going to be 6. What happens when we get to the fourth derivative? And this is what it was asking about. Well, what is the derivative of a constant? If you remember, this constant here has an x to the 0 power. So that means we're going to bring the 0 down and multiply. So that becomes 0. And what is the derivative of 0? Well, it's just 0. So what we can say that is true about the nth derivative of this function when n is greater than or equal to 4 is that it equals 0. Okay, so now let's look at the second one. The first four derivatives of this function is what we're going to find, and then we're going to try and write a generalization about what happens with any derivative of this function. Okay, so my first derivative is going to be, well, the derivative of e to the x is e to the x. I'm going to use that little trick I did on the last video where this is a -1 here, right? So I'm just going to bring that -1 down and multiply and then leave the rest the same. So that becomes negative e to the negative x. All right, so the second derivative, I get e to the x, that stays the same. But this -1 comes down and multiplies, so that becomes plus e to the negative x. The third derivative is e to the x. The negative multiplies, so I have minus e to the negative x. The fourth derivative becomes e to the x plus e to the negative x. So you can see we have a pattern going on here. So what I can say about this generalization is that when n is odd, the function equals e to the x minus e to the negative x. When n is even, it will equal e to the x plus e to the negative x. So the derivative will equal that, and the derivative will equal that. So if I just asked you simply, okay, so what's the 27th derivative? You could tell me, oh, well, 27 is odd, so the 27th derivative is this one up here with subtraction. Okay, so that's what makes it a nice general statement there. So let's look at the third one. The third one wants us to find the first four derivatives here of y equals 1 over x, and then we're going to write a formula. We're actually going to write a formula for this one. This one gets a little crazy, but so instead of starting out with 1 over x, I'm going to change that. That's going to be y equals x to the -1. That's going to make it a little easier. We can apply the power rule. So the first derivative is equal to -1x to the -2. The second derivative is equal to +2x to the -3. The third derivative is equal to -6x to the -4. And the fourth derivative is equal to +24x to the -5. Huh, interesting. So we have to kind of take into account all of these pieces. So let's start with the coefficient. What happens with the coefficient? Well, very simply, to start with, the sign changes from negative to positive, negative to positive. So when my derivative is odd, it's negative. When my derivative is even, it's positive. So it can start by saying that it's -1 to the n power. So if I'm taking the second derivative, that would make this positive. If I'm taking the third derivative, that would make this negative. -1 to the third power is negative. So that's going to take care of that piece for me. Now I need to figure out how I got 1, 2, 6, and 24. Well, and not many of you will recognize this, but a couple might pick up on the fact that that's a pattern of factorials. Remember, factorials are the number plus every number below it. So 1 factorial is 1. 2 factorial is 2 plus 1. I'm sorry. Correct that. I don't know what I'm telling you. It's not plus, it's multiplication. I'm losing it, guys. I'm sorry. Factorial is the number times every number below it. There we go. So 1, this is the first derivative, so that means we're going to take 1 and that's it. So that became the 1 there. 2, because we're talking about the second derivative, this is where n equals 1, because that's the derivative number, n equals 2. So we're going to do 2 times 1, and that'll get me the 2 here. When n equals 3, 3 factorial is 3 times 2 times 1. That's where the 6 comes from. And when we're taking the fourth derivative, we're going to do 4 times 3 times 2 times 1, and that would get us 24. So that's why I paused. I was like, oh, hold on, adding doesn't get me the numbers I'm looking for. So anyway, what I'm looking at here is I'm multiplying by n factorial. So put a little exclamation point in there, right? All right, now I need to be able to get the exponent. Well, the exponent here, it looks like I'm just dealing with the negative, so it's the negative of, and how could I get 5 knowing I was taking the fourth derivative? 4 knowing I was taking the third derivative. 3 knowing I was taking the second derivative. If I just take the n and I add 1, that's going to get me that. Now I could rewrite that and write that down as the denominator if I wanted to because of that negative exponent. But this craziness, that's why I didn't want you to do this one on your own, this craziness becomes the general formula for finding all of those derivatives.